this case study is a fantastic one, which happened in some part of United States years back. First, understand the process. Whoever is in doubt, please ask me. Okay, I stop deliberately here and there. Process is injection molding. Injection molding where? Injection molding at my end. I am going to do injection molding, but in the pot, my input is this. This I am getting from my suppliers, or rather one supplier. After injection molding, the pot will be looking like this. Is it clear? Right. Is the situation first of all clear? If anybody is having any doubts, please ask. No doubts? So now the botheration is about this particular diameter. Okay, imagine the pot has been shown in a bigger way. Okay, unfortunately the case study was given in inches, right? So for our convenience, I converted that into metrics, right? 3.556 mm plus minus 0.076, right? 003 inches means 1 inch is approximately 0.025 microns. So it is 76 microns. Is clear? You understand this as an exaggerated view. If no doubt, I will proceed further.
Sir, what is 0.40, sir?
Lot of noise I cannot explain. Somewhere I am getting noises, sir.
0.140. Plus or minus 003 is you change
inches,
inches, sir.
Inches. Oh no, they are given in inches. I changed it to millimeters here. Let's see.
Millimeter plus 0.14 minus 3 micron.
No. You don't understand this. 0.140 is the base value that I converted as 3.556.
Yes, sir. Okay.
The tolerance is plus minus 003 inches. 3000.
Yes, I understand.
That has been converted as 076. Right. I just proceed now. So at my end, okay, at my end, after injection molding, the process is established to be a stable process, still with a lot of non-conformities. Very difficult to understand. I'll technically go now. Friends, see the same size is shown here. Okay, be happy with inches. Okay, our concern is to understand the basic concepts. So what is my answer? I always raise this question, right? N is equal to
5.
Always 5.
5, sir.
Oh no, don't say always 5. This case is 5. M is equal to always 25.
This case 27.
27.
27.
M is equal to 27. Clear, na? So say first set subgroup 140, 143, all inches, my dear friends. Average, range. Clear? So second one goes like this. Then one average, another range. Please see the total is given here. These two are the totals. This is sum of X bar. What about this? This is sum of?
Sum of
Sum of R bar.
Not R bar. R.
R.
I expected this. Sum of R, right? We are yet to calculate R bar or X whole bar rather. Right. So I'm just proceeding. So we have to now find out x double bar. Okay, it's going to be very simple, not a complicated one. Similarly, r bar. Right? Can I just make it, sir? What is your x double bar?
What, sir?
X double bar. Sorry, x double bar. I'm right. X double
X
bar.
double bar 3797.4 divided by 27.
Yeah.
0.14, sir.
Yeah, you are right. X double bar is 14. No, I go by this 140, sir. Okay, I agree with you. 0.140 only. Okay, doesn't matter. What is R bar value?
233 divided by
233, similarly divided by 27.
27.
8.6.
8.62.
8.63. 8.63. Barabar na? Right. I'm just proceeding. So we computed X bar, X double bar, sorry, X double bar and R bar also. Correct, na? R bar 8.6. Now, please find out D3R bar or D4R bar. What is the D3 value when D3 is equal to?
D3 is equal to 0.
0, 0.
Brilliant, brilliant. Thanks. D4 is equal to? D3R bar itself is 0.
D4 is equal to 2.114.
114 into 8.6. How much? 2.114. All please do that. You will gain the confidence. I am also doing 8.6. Correct now? 2.114.
18.2.
18.18.
18.2. 18.2. All are with me?
Sir.
Yes, sir.
Yes, sir.
Correct. 18.20. Now, indirectly, I am going to explain you what is called homogenization. Just see that. Now you have to compare your 18.2 with all R values. I repeat, compare 18.2 with all R values, ranges. Anything succeeding? Anything succeeding?
No, sir.
No. No. That means no special cause variations. We can firmly say, right? No special cause variations. All are with me? Shall I proceed further?
Yes, sir.
Sir, we
It is
will
a very big
compare
case study.
to,
I simplified it. Sorry.
sir,
Compare,
we will
compare
compare to
18.2 with all R values.
R values.
Ranges. I'm showing it, na, the screen. There is a circle also. Nothing is exceeding. Fine. Now, please tell me your x double bar plus a2r bar and x double bar minus a2r bar values. Kindly do it, my dear friends. Upper control limit for x bar chart, lower control limit for x bar chart.
Yes, sir. UCL is 145.6261
Okay.
and LCL is 135.69.
Okay. We can always call 0.135 also. Okay. Since it is inches. You may be right. Kindly wait. So, all got the answers? UCL X bar and LCL X bar. Okay, good. Right, friends, I'm just showing you the answers. Please check 135, 145. Okay. If you are okay, I shall proceed further. Now, what we are supposed to do once we know the control limits for X bar chart also. What is it we are supposed to do? We got the control limits for R chart. Immediately we have done one thing. Same thing you have to repeat here. Na? What is it we are supposed to do? We must now compare these two limits with all X bar values. Okay, now these limits we have to compare with all X bar values. My dear friends, can you understand one thing carefully? Nothing should be less than 135. Nothing should be more than 154 or 155. Is it okay?
Sir, 145.
Sorry. 145. I perfectly agree with you. Nothing should be more than 145. Typo, sorry about it. So, I'm just deliberately going back. Please compare, sir. Anything is compare only X bar. Keep the readings with you. Just compare. First, compare only upper control limit. Anything is exceeding. If you are convinced, come back to lower control limit, then compare. So 145, 135. Ne? No, nothing is exceeding. Here also nothing is exceeding.
Yes, sir.
Okay, na? Convinced?
Yes, sir.
What is the meaning then?
No special cast series. Sir.
Brilliant. But it is hard to believe that there are many measurements out of not control limits, out of specification limits. Just see, they are now bringing in all spec limits. All spec limits. They compared individual measurements. Please understand this carefully. Not average, not arithmetic mean. They compared individual measurements. See how many points have gone completely out of control limits. It had happened in X bar completely. Okay. Only this much within the limits. Please see the R chart. Please see the R chart. Oh, sorry. But there is a problem here. No. This is okay. This is X bar, no doubts. This is R, no doubts. Friends, please recall our tolerance range plus minus 3 tau. I said. Are you able to recall? Plus minus 3 tau. That means totally 6 tau. How much is that? Just for our interest. 6 into 0.025 is 0.15. But please see how many points are within tolerance range. Forget about specific control range, tolerance range. 6, 3, 6, 6. Only 4 readings are in the acceptable region out of 27. I'm talking about range in isolation. X also deviated individual values. Then if you go by the range also got deviated. Out of 27, only 4 readings are within the acceptable tolerance range, not process range. If you are clear on this, I shall proceed further.
But sir, but average is everything below the limit, sir. Range only out of spec.
No. X also individual I showed you. Please see here. X also individually. Similarly, R also out of 27 only 4 are in the region. acceptable region.
Or also for individual.
Sir, R cannot be for individual. Na? Range means there should be at least 2 readings.
So in this example,
Then only you will get a range. Na? X can be individual. Range can never be individual. For range, you have at least 2 readings. Na? Then only you can compare. Min-max difference. I stop here. If you could
sir,
understand.
if I'm not wrong, so the specification limit is within the control limit. Is this what those two graphs are showing?
Need not be, sir. Need not be. That's what, I don't know. When yesterday or day before, I was just hinting you. There is no necessity that always your control limit should be within spec limits. If you are very particular, take this case, draw yourself and then convince. Need not be. Finally understand. Where from you are getting the spec limits? Mr. Vijay? Where
From
from?
the drawing or the
Drawing,
customer?
sir, drawing.
Straight from the drawing, that's all. Straight from the drawing. Where from you are arranging at the control limits?
From a process.
Well, process.
Excellent. From your process. Excellent. From your process. All you have to run the process, produce parts. From there, you have to arrive at your control limits. Then only the control limits can be called as statistically arrived control limits. Even I was hinting you, right? Some companies are blindly saying, what is the total tolerance? 100 microns. No, you have to operate your process within 50 microns. I told you, no, this is not acceptable. Are you able to recall? Not at all a good practice. It's not at all a good practice.
So if that's the case, then we need to look for better process controlled equipments. Is that the right thing, sir?
Perfectly all right. Perfectly all right. Don't say only equipment. That could be, all 5Ms only you have to consider. Clear, man. All
Okay, fine.
5Ms and only you have to consider. Mostly equipment, I agree with you. Most of the cases I have personally witnessed, okay, machine produces a lot of variations. If not machine, the friction. Clear. So
So,
this point is,
the one clarity what I got is of my whole life I just believe that to arrive to draw the control chart we must meet the tolerance range, but this is an eye opener. Yeah.
thanks for that. Please, a typical case, ne? A typical case. That's why, I never gave you the answer. I was just questioning you. Where from you getting the tolerance drawing? You said. Where from you getting the control limits? You said from the process. May not be, sir. The simple. All cannot become good engineers, ne? All cannot become good engineers. All cannot become good mechanical engineers or chemical engineers. Cannot be the case. But unless until, what is the movie? Three Idiots. This was the topic, right? Three Idiots movie. In Tamil also it was, recreated as Nanban, right? Can you imagine Ilayaraja acting in the movie? Great music director. He cannot become a hero in a movie, right? Similarly, can you expect Rajinikanth to become a music director? Cannot. All are having, blessed with abundance of, talents. But does not mean that one talent can be applied everywhere to become successful. It's as simple as, right? If you are okay with this, range business, I can continue further. Now, they started focusing on the incoming source variation. Okay. When Mr. Vijay said, can it be because of machine? I said, maybe. I never said, yes, it is going to be. Please see this typical case. Incoming source, that created a lot of variations, because they were getting the part. You remember? I showed you the part. The part was received from the supplier, right? They were supposed to maintain within so limit. They could not. The supplier said, over and above the supplier part profile, I was creating my injection molded parts, right? Now, they requested, very interesting case, I'm telling you, they requested the design department to modify the tolerance. No plus minus 0.003 will work out. Okay, what is it you want? From the actuals, I repeat, from the actuals they gathered, they arrived at the specification limits, like plus 10,000, minus 15,000. I just circled and then showed you. Plus 10,000. Similarly, please see the typical case. You need not always plus minus 15,000 or plus minus 10,000. Plus may be in one side, negative may be in the other side. Here, plus minus, plus 10,000 minus 15,000. Temporary adjustment. I'm telling you, this was a temporary adjustment, right? Then they started taking up the case with the suppliers. Finally, supplier agreed, yes, sir, I could not able to produce as per the stipulated limit because so and so problems were happening at my end. Then finally, they arrived at, brought back the regular tolerance of plus minus 3,000. Okay, with the revised tolerance, they have gone for 100% check. They improved the process consistency and the supplier said, very important, the supplier said, supplier process was improved. Then tolerance was brought back to the original tolerance range. That was plus minus 0.003 inches. 3,000. Great, man. Right. Can you conclude, sir? What is your inference from all our discussions? What do you infer? What do you understand? Something new for the day.
Compared to range, sir, to our range, what is the status? Then we will decide our process variation.
Okay. First, you have to look at the range. I agree with you. Okay, I agree with you. I agree with you. Technically, you are right, but statistically, what do you infer? Anybody else? Statistically, what do you infer? Always friends. Okay. Just point of interest. Differentiate into two ways. One is that technically, what is that you are going to do the shop floor? Okay, actionable points. Second one, look at it the other way. Statistically, what do you infer? If you are not able to separate out, it's going to be confusion. Right? Statistical inference. Second one is accordingly make your process to respond technically. My overall understanding was this. Can someone read it loudly for the benefit of all? Final conclusion.
All stable processes may or may not avoid huge rejections.
Yes.
Only capable processes will avoid huge rejections.
Brilliant. Brilliant. Clear, na? Anyway, first we have to be concerned about the stability. I'm not saying no. I'm not saying no for stability. But once you are stable, it does not mean that you are going to be capable. If you are okay with this, I close down.
One of my measured value is crossing the control limit, then still my process is stable, sir.
Okay. Interesting one. Anyway, finally, you have to look at one thing very carefully. Whether how far you are able to get a bell curve. How far you are able to get the bell curve. Finally, understand, Mr. Vijay, in this fashion. In X bar, one value is crossing the control limit. Right? I'm just dramatizing the situation. Very next point in X bar chart itself is crossing the lower control limit. Earlier upper control limit, now into lower control limit. Then, if you are averaging out, you are going to get a bell curve. Na? If both are in a similar fashion, deviated from the mean in a similar fashion, you are going to get a bell curve. Yes or no?
Yes, sir. Yes.
Always look at the bell curve. No harm going by control charts. Right? The best is bell curve. No harm in going by control chart also. It may go like this, na? Erratic way, but equal. Okay, wide spread but equally distributed. I mean, communicating properly. Wide spread but equally distributed compared to the mean process mean. To the best of my little knowledge, this particular case will fall under that category. Okay, now. Anybody else? Shall I close it down?
Okay, sir.
Nobody is allowing me to close down. What happened?
Yes, sir, sir.
Went to
Please.
the case study. Nice, friends. So, with this, kindly recall, whenever you get the control limit, first to compute control limit for what? X bar or range? I'm not getting the answer. First, you have to get the control limit for
X bars.
9. First, control limit for range. That's what you have done in this case. Okay. Then compare with all ranges. Okay. Convince yourself. Then come back to X bar. Compare with all X bar values. Convince yourself. If you are exceeding the control limit, what next? That is what I'm going to answer now. Very well done. Thank you so much.
Yeah. So I know, Mr. Manivannan for past, 10, 12 years. So he is like, Sachin Tendulkar for quality and training. Okay. To attend Manivannan's program, you need not to have any engineering background or statistical knowledge, etc. So he will, make you to learn and pace you up with the others, within matter of, no matter of time. And moreover, the style of workbooks. See, if you attended his classroom training, you come to know. So he will leave all the most important things blank. Okay, so he make the participant to write on it, and he will also make them participative. Completely he will take them through the program in a lively manner.